We had seen that numbers, if they are not rational, will be called as irrational numbers. Further, if I try to represent irrational numbers by a decimal number, I find that they do not terminate and also they do not repeat. That is, they are non-recurring and non-terminating decimals. Now we know that under root 2 is an irrational number. So does that imply that if I put any number under the under root sign, that will become irrational? So what I do is, I write the first 10 numbers and I put them under the under root sign. So will all these numbers be irrationals? Let us find out. Under root 1. We know under root 1 is equal to 1 only, which is a rational number. Hence, under root 1 is not an irrational number. Similarly, if I move to under root 2, we know this is irrational. Under root 3 is also irrational. What about under root 4? This is a perfect square. So under root 4 gives me 2, which is a rational number. Hence, this is not irrational. Root 5 is irrational. Similarly, root 6 is irrational. Under root 7 is also irrational. Under root 8 is also irrational. But again, under root 9 is equal to 3, which is a rational number. Hence, this is not an irrational number. Under root 10 is an irrational number. So we see that if I put a number under the under root sign, it does not guarantee that that number becomes an irrational number. If it's a perfect square, then we can represent that under root number, under root of a perfect square, by a rational number. Hence, that is not an irrational number. So that's how I get that from 1 to 10, if I put them under root, all numbers would not be irrationals. There are some that are irrational. We know under root 2 for sure is an irrational number. We've seen that. Now if I add, subtract, multiply or divide this irrational number by some rational number, let's say 3. So I get this 3 added to an irrational number, that is a rational added to an irrational number, irrational subtracted from a rational number being multiplied by an irrational number, and a rational number being divided by an irrational number. So I get these 4 operations: addition, subtraction, multiplication and division of an irrational with a rational. Now what would this give me? A rational or an irrational number? That is the question. Let us look at this. I want to find whether 3 minus under root 2 is an irrational number or a rational number. So what I do is, I'll suppose that this is a rational number. Let us suppose that this is a rational number, say x. So you call this rational number as x. So what can I write? I can say that 3 minus under root 2 would be equal to x, because I'm saying that this is a rational number which is x. So I can say this. Now from this, what I can get is, moving away x to the left hand side and under root 2 to the right hand side, what I get is 3 minus x would be equal to under root 2. I bring x here and I take under root sign the other way. So I get this 3 minus x is under root 2. Now I know that 3 is a rational number. I know x is a rational number. And we know that rational numbers are closed under subtraction. So subtracting these two rational numbers also gives me a rational number. That means that 3 minus x would be a rational number for sure. Subtracting two rationals gives me a rational. So I get that 3 minus x is a rational number. Now I get that left hand side of this expression is a rational number. What about the right hand side? If left hand side is a rational number, that implies the right hand side also has to be the rational number. So this implies that under root 2 is a rational number. Now, is this correct? No, we already know that under root 2 is an irrational number. So this statement is a contradiction. This is a contradiction. This means that whatever we had supposed earlier is wrong. We had supposed that 3 minus under root 2 is a rational number, But this contradicts. I get under root 2 as a rational number, which is a contradiction. Hence, whatever I had supposed initially is wrong, which means that 3 minus under root 2 becomes an irrational number. So we have seen that subtracting an irrational number from a rational number, we get an irrational number again. Now let's look at addition of a rational with an irrational. What about this? Again, let us suppose that this is a rational number, say x. So I assume that this is a rational number x. That means 3 plus under root 2 is equal to x. Now again, I can bring x this side of the equation and I can take under root 2 the other side. What I get is that 3, if I bring this here, minus x would be equal to, I take under root 2 the other side, negative under root 2. This is what I get. Now I know again, x, a rational number. We've supposed that x is a rational number. 3, again a rational number. Rational numbers are closed under subtraction. So subtraction of these two rational numbers gives me a rational number again. So I can say that 3 minus x would be a rational, which implies that negative of under root 2 should also be a rational number. Now if negative of square root 2 is a rational number, then this would further imply that under root 2 should also be a rational number. Now this is a contradiction. We know this is not true. Root 2 is an irrational number. If this is a contradiction, what about this? Whatever we had supposed was wrong. That is, we had supposed this to be a rational number. That is wrong, which implies that this would be an irrational number. So what I get is that a rational added to an irrational gives me an irrational number again. So addition and subtraction of a rational number with an irrational number gives me an irrational number again. What about multiplication now? Or division? So can you say that a rational number divided by an irrational would give you a rational number or an irrational number? Now that is the question. We can follow the same process again. Let us suppose that this number is a rational number, say x. If this is a rational number, what I can say is that under root 2 by 3 is x. This is what I've supposed, a rational number x. Now what I can do is cross multiply. So this implies that under root 2 would be equal to 3 times x. So I get this. Now what I know is that multiplication of two rational numbers gives me a rational number again. Rational numbers are closed under multiplication 2. So I multiply 3, which is a rational number, by x, which is a rational number again. So this side, which is the right hand side, is a rational number for sure. Now if right hand side is a rational number, that implies the left hand side is also a rational number. So what I get is that under root 2 is a rational number. Now again, we get a contradiction. This is a contradiction, hence whatever we had supposed was wrong. We had supposed that dividing a rational number by irrational number gives me a rational number. But this is wrong. So dividing an irrational number by a rational number, we do not get a rational number. Instead, we get an irrational number. So this number is an irrational number. So we've seen division gives me an irrational number. What about multiplication now? That is a rational number being multiplied by an irrational number. How do I get this? Again, we can follow the same approach every time. All I need to do is assume that this is a rational number. If I get a contradiction, then I can say that that statement is wrong, whatever I had supposed. And if I do not get a contradiction, then yes, this would be a rational number. So what I do is I again start by supposing that this is a rational number, and let's call that rational number x. So I suppose that this is a rational number x, which gives me that 3 times under root 2 is x. Again, cross multiplying, I get under root 2 is equal to x divided by 3. Now x is a rational number, 3 is a rational number. Division of rational numbers gives me a rational number again. Why? Rational numbers are closed under division 2. So this is a rational number. That is, right hand side is a rational number. So left hand side also has to be a rational number. Now that gives me that under root 2 is a rational number. Now again, we know this is not true. I get a contradiction. If I get a contradiction, that means that whatever I had supposed initially is wrong. So that is, if I multiply a rational with an irrational, that is 3 times under root 2, that is not a rational number, but instead that would be an irrational number. So we've seen addition, subtraction, multiplication and division of irrational number with a rational number gives me an irrational number again. So under root 2 is irrational, and all these expressions, addition, subtraction, multiplication and division of a rational number with an irrational number gives me irrational numbers again. So after a lot of years, there was a whole list of irrational numbers that actually came up, and mathematicians found that pi 2 is an irrational number. I know that we've studied so far that pi is equal to 22 by 7, but that is not true. Pi is not equal to 22 by 7, but instead pi is approximately equal to 22 by 7. For our convenience and ease, we use that pi is equal to 22 by 7 because it is approximately equal to 22 by 7. That is, if I try to represent this number as a fraction, it is very close to 22 by 7. Hence, for our own ease, what we do is, we take pi to be equal to 22 by 7, but that is not true. That is just for our own ease. So we see that under root 2 is an irrational number. Further, addition, subtraction, multiplication, division of a rational and irrational gives me an irrational number, and pi 2 is an irrational number.